Ladies and gentlemen, esteemed guests, brilliant minds gathered here today. Yang berbahagia, Datin Dr. Zuriati Zakaria, Yang berusaha Mr. Yaya bin Sedi, Yang berusaha Associate Professor Dr. Sim Seong Fong, the IKM Committee, teachers, international students from Japan, South Korea, Taiwan, and so on, and our distinguished participants. Welcome to the electrifying opening ceremony of the Young Ambassador for Chemistry 2023 at Institut Pendidikan Guru Campus BATU Lintang, Kuching. So today, we set sail on a voyage of innovation and exploration where chemistry ignites the spark of change and sustainable development lights our way. Let's embark on this accelerating journey together, starting with a warm welcome to our very own guiding star. Please give a round of applause for the Acting Director of Institut Pendidikan Guru Campus BATU Lintang, Mr. Yaya bin Sedi.
Yes. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Wassalamu ala asyrafil anbiya'i wal mursalin. Salam Malaysia. Firstly, on behalf of Institute Teacher Education BATU Lintang Campus, I would like to welcome Yang berbahagia Datin Dr. Zuriati Zakaria, Vice President of the Malaysian Institute of Chemistry and co-leader of the 9NAS 2023 Local Organizing Committee. Also, I extend my welcome to Professor Dr. Yi Wong, Chu Seun Lan, and Associate Professor Sim Seong Fong, respected members of the Organizing Committee for the Young Ambassador for Chemistry Kuching 2023 events, teachers, and all participants under respected IUPAC Young Ambassador of Chemistry program. I am happy to have this diverse group from around the world, from Taiwan, Korea, and Japan, and from our local area at Institute of Teacher Education BATU Lintang Campus. As we start this important event, I want to say thank you for the amazing opportunity to host this event, which let us celebrate the great success of 8 nights conference in Taipei. We are very thankful for the chance to follow the great example set for those before us, and we promise to do our best to make everyone feel welcome. Ladies and gentlemen, today I stand before you as someone who has seen the power of young people like you in creating a better future. You are here as a young ambassador of chemistry, a subject that is very important to life and universe itself. I am moved by your love for this subject and your commitment to sustainability and protecting the environment. You, as the young people of today, are in a special position in this quickly changing world. You have a lot of access to digital technology and a lot of information, which lets you explore complex chemical processes and find new solutions to environmental problems. Your education in biochemistry and industrial processes. This knowledge increases your understanding the impact of chemistry. As an educator, I am here to support and encourage you on your journey. Your mission as a young ambassador of chemistry is to use your knowledge for the good for this planet. Let your action start a spark that inspire others to follow you. Together, let's create small changes that will eventually grow into a way of sustainable development and environmental protection. Finally, thank you for your dedication and commitment to making the world a better place through chemistry. The future is in your hand.
Okay, thank you, Mr. Yahya, for your inspiring words that have set our hearts aglow with excitement. As we continue to illuminate the path of knowledge and discovery, let us welcome the next luminary guiding us through this enlightening event. Please put your hands together for Associate Prof. Dr. Sim Seong Fong, a prominent and one of the most loved lecturer in UNIMAS, also a guiding star in local organizing committee of YAC 2023.
Very good morning to everyone, and especially our guest, Vice President from Institute KIMIA Malaysia, yang berbahagia Datin Dr. Zuriati Zakaria, and also yang berusaha Encik Yahya bin Sedi, okay, and also to our young chairpersons, Dr. Yvonne, and also I want to thank everyone who are here, especially the teachers, the international participants, and the students, as well as the organizing committee. So you can see this is the photo taken yesterday. All right, this is our committee member from Institute Pendidikan Guru Campus BATU Lintang, who is the host for YAC this year, and we can sign consultant with Jabatan KIMIA Malaysia. We have University Malaysia Sarawak, and also University Technology Marat. Myself is from University Malaysia Sarawak. Okay, now maybe to give you a little pictures about who are we. All right, we are from Institute KIMIA Malaysia, and we abbreviate ourselves as IKM. Okay, Institute KIMIA Malaysia, IKM, and we have many branches scattered all around Malaysia. You can see here there are 1, 2, 3, 4, 7. There are altogether 7 branches. Okay, Northern branch, Perak branch, Terengganu, Pahang, Southern Sarawak branch, and Sabah. Okay, and we have our parent institute in HQ. All right, so we are from IKM Sarawak. Okay, we are working closely with our parents from Institute KIMIA Malaysia headquarters. All right, now you are attending Young Ambassador for Chemistry. In fact, this is not new in Sarawak. We have had it held in 2016. Back then, the host was SMK Sakura. So we had 2 days of events with the teachers and also the students as well. So as you can see here, it was hosted by SMK Sakura, where teachers shared their ideas for the chemistries of products and related to the products in Sarawak. Okay, and we have also sharing ideas, interesting ideas about what we could do together in chemistry. Okay, and we have students coming together to design the cosmetic line. Right, it was a very fun day, and I enjoyed it in 2016. Okay, time flies, it's 2023, and we are back in YAC, and thanks to IPGK BL for hosting this event this year. Alright, in fact, IKM Sarawak has also many NGO works with IKM HQ in education for chemistry besides YAC. YAC is one of them. We have a long-term project. It's a decade long of partnership between IKM with the Jabatan Pendidikan Negeri, where students and teachers, you are actually part of them, and we work with government and private agencies as well as universities. Okay, all what we want is really to promote science. Okay, we know that we need science. Okay, we need science for the world, to make it a better world to live. Okay, so we would like you to continue this journey. You can see that 2016 I probably was much younger. 2023 I have grown old. See, I can't be forever young, and you need to take over this baton and continue to run this world. All right. So we are encouraging students like yourself to take out science as your career. Okay, with the help of your teachers and the help of us. So we'll continue to get scientists Okay, so this is one of the projects that we are doing continuously since 2011. Okay, it's called Carnival KIMIA Malaysia. 2011, we had it in UNIMAS. Okay, that was the very first time we worked with Jabatan Pendidikan Negeri. Subsequently, we had it in 2013, College of Dila. Familiar to you? Yes, we had that at your school. And then next, 2015, UNIMAS again. 2017, MRS and Betong. And then 2019, SMK Marudi. And 2022, SK Long Bedian. So we are actually moving out of the cities and going into the rural areas because we believe that talents are in the rural areas. That we are promoting science and we are trying to facilitate and supporting learning of science in the rural area. So that's what we have been doing. And today, for the same objective, and would like to invite you in part of this journey, promoting science and getting yourself excited about science. All right. Now, to end my speech here, I'd like to wish you an enjoyable and experiential day with us. All right. Thank you very much.
Thank you, Associate Prof. Dr. Sim Siang Fong, for igniting the passion within us and guiding us on this remarkable voyage of this learning and collaboration. Our journey of exploration and discovery wouldn't be complete without the insight of visionary leaders. Now, let's welcome our next guiding light, the Vice President of Institute KIMIA Malaysia and Joint Chairperson of Network of Intern Asian Chemistry Educators 2023 Local Organizing Committee, Datin Dr. Suryati Zakari.
Yang berbeza, Encik Yahya bin Sidik. Now today I found out that he is a student of my husband. And then Associate Professor Dr. Sim Siang Fong, the chair of YAC event. And then Yvonne Chu, our rising star in IKM. So, ladies and gentlemen, boys and girls, welcome, and then also international participants, welcome to this event. I have always asked young people, why are you not taking chemistry? They say, well, it's smelly, it's toxic, it's explosive. That's their mind. So we feel that young people always see the negative side of chemistry. Our positive side of chemistry has not been highlighted. What do chemists in my generation and before, what do they do? We have played a vital role in medicine, for instance, pharmaceuticals, vaccine. We have chickenpox vaccine, many vaccines, and agriculture, fertilizers, pesticides, herbicides, to make our crops grow well, good quality, and we have food security. And then energy, we have petroleum to run all our cars and our electricity. And materials, look at so many cars and so many materials in the world. They're all chemicals. And consumer products, every day you put cream on your face and everything. These are all chemicals and chemistry. But alas, because of our effort to make our quality of life better, there are also adverse effects. Because of all this human activity, there's a lot of emitting greenhouse gases, carbon dioxide and all. And what is the effect of it globally? You will have a climate change. Climate change where you will have El Nino, now the world is warmer. And then you have typhoons and flooding. I remember when I was young, we don't have this kind of things. But now, I'm now 73 years old, see how long I've lived. And you can see that I can feel the effect. When I was in school, we always go for picnics. It was all very comfortable. But now my children don't go to picnics anymore because it's so hot. You know. So we have used a lot of resources from the earth. We dig tin, we dig gold, we dig many things. We have used a lot of petroleum. What is the future then if everything is finished? So you are the young chemist who's going to make it right, to make us survive on this planet. And that is why this Young Ambassador of Chemistry program is to look at how we can we have to change your purpose now. Last time you want to make new chemicals, new things, without thinking about what is the effect. So now we have the sustainable goals that will make us survive for you and as well as for the future generation. But I will not dwell on that because Dr. Yvonne will be speaking to you about the sustainable development goals. And today, of course, the young last time was fun because there have been products like making lipsticks, making cream and all that. But in this program, you are going to experience some experiments that will be quite just examples of experiments that will make our future better. Yeah? So I would really like to thank the IPT, Mr. Yahya, for hosting this event, and also our local organizing committee, which from people from UNIMAS, UITM, Jabatan KIMIA Malaysia, Camp Science, for providing some chemicals for our event. And on Sunday, you're going to have two professors who's going to show you some fun chemistry on Sunday, right? Professor Udi and another professor. So again, I would like to thank all teachers, all foreign participants, and all students. We hope that you are going to be our ambassador in chemistry and also work towards a better future for all of us. With that, I officiate this event. Thank you very much.
Thank you, Dr. Zuriati Zakaria, for illuminating the path of inspiration and empowerment for all of us. With the guidance of these esteemed luminaries, let's now embrace on the illuminating voyage of Young Ambassador for Chemistry 2023, where the magic of chemistry meets the power of our collective dreams for a brighter and sustainable world. Ladies and gentlemen, with the inspiring words of our esteemed speakers, we officially inaugurate the 9th network of Inter-Asian chemistry educators and Young Ambassadors for Chemistry 2023 at Institut Pendidikan Guru Campus BATU, LINTANG, Kuching. Okay, thank you. I would like to share a profound quote by Professor Gilbert Newton Lewis that perfectly encapsulates the essence of this program. In chemistry, our theories are crutches. To show that they are valid, they must be used to walk. So today I believe we will be able to give you those crutches to walk and you guys work your journey in chemistry. Okay, now let's go to our next part of the event. As we continue to our illuminating journey, let us welcome the final guiding star to shine light on the connection between chemistry and sustainable development goals and a teeny tiny brief about the experiment that will be conducted later on. Please join me in welcoming the rising star, as Datin mentioned earlier, Assistant Prof. Dr. Yvonne Chu Xuanlang from the YS 2023.
Hello everybody. Great pressure when it says like a rising star. Right. Good morning everybody. I'm Yvonne. I'm an assistant professor at University of Malaysia. And today I'm here to tell you more about chemistry and sustainable development goals. Right. So I would like this section to be a little bit more interactive, where I will see some questions and I hope to get some response from you. Is that okay? Great. So, my first question is, Do you know why chemistry is often called the central science? Any ideas? Do you know what the central science means? It's like the middle or the central of everything. Any ideas? Students? Great young minds? Why would you call chemistry as the central when you have chemistry, physics, and biology? Yes?
Because many aspects of science involve chemical reactions.
That's correct. Yes, part of it's correct. Let's give her a round of applause. Any reason why why you think chemistry is the central science? No? Any more from there? If no? Okay. All right. So chemistry is considered the central science because one of the reasons is it is the vital bridge that's connecting physics and biology. Right. Another reason is because a lot of chemistry studies relates to molecular atomic level understanding. Right. And a lot of the chemistry fundamentals that we've learned are utilized in solving real-world problems. So that is why chemistry is often considered as the central science. Now, the other part of my title, Chemistry and Sustainable Development Goals, you'd expect another question from me asking you, what is Sustainable Development Goals? Have anybody not heard of Sustainable Development Goals? Please raise your hands. Anybody not heard of that? Everybody knows. Great. So, Sustainable Development Goals are a set of 17 global goals adopted by the United Nations in 2015. So, on screen right now, you're seeing all 17 goals. They basically provide a shared blueprint for peace and prosperity for people and the planet. So, you can think of it as goals that are important for all of us for the betterment of society and our planet. Today in particular, we'll be focusing on 5 different goals. So before I continue that, I would like you to look into your manuals right now. That's your cheat code, right? If you don't have that manual, fear not, please scan the QR code and you can get a colored copy of the manual. So if you have a device and you'd like to get a QR colored copy of that instead of a black and white, please do scan me, not me, but the scan the QR code on screen.
Yes.
Is everybody all right with that? Now, let's proceed with my next slide that I'll be asking you, what do you think the 5 goals are? What are we focusing on in today's experiment based on the lead manual? Any ideas? Quick shout out. If you look into the booklet and the table of contents, there is one area that you should specifically look into. Where is that?
Clean water.
Clean water, yes. Number 1, clean water and sanitation. So SDG 6. What is the next one, guys? Yes, affordable and clean energy. Okay, what's the next one then? Industry, innovation, and infrastructure. That's SDG number 9. What is the next one? Yep, that's correct. Responsible consumption and production. And what's the last one? Yes, climate action is the very last one, which is also the one that a lot of people strive for at this present moment because our climate is clearly seeking our help. Now let's zoom into our first goal of today, which is goal number 6, clean water and sanitation. So you can see on screen right now, somebody's hands are washing something, right? Clearly, when you're using water in your day-to-day life, you're using it, you need clean water for your everyday life. From washing fruits, from drinking, from a lot of different things, right? Water is an important source, and having clean water is definitely something that you need to strive for. So here you can see on screen, chemistry can play a crucial role in ensuring access to clean water and sanitation, such as water purification, wastewater treatment, water quality monitoring, etc. So you would closely see this relevant to our first experiment today. If you flip through this lab manual, I'm showing you how to use this, fully utilize this lab manual. If you flip on screen and go to page number 5, you would see the first booth on water analysis experiments. Right, in that particular booth, you will have observation and turbidity tests, pH tests, and also the anion and cation tests, I believe. Identification of dissolved ions. So these 3 are relevant to water quality monitoring, and those are very, very relevant to how do you get clean water supply, how do you identify these areas. And I'll leave it to the good hands of Jabatan KIMIA Malaysia staff, which you will be noticing in the biology lab later on. So all of the teachers with the tables later on, you'd see biology lab, chemistry lab, and physics lab. That's where they will have this particular experiment in the biology lab. Okay, so please stay tuned and have fun when you're doing those experiments because you see a lot of colors, and I hope that you utilize this with a mind that it is helping our world in terms of water quality monitoring as well as being able to do these analysis at home. What's the bigger impact that it would give? Okay, what's our next goal again? Energy, right. So goal number 7 is affordable and clean energy. So if you flip through this manual again, you will reach to an area where you talk about the making of solar cells and water electrolysis experiment. Anybody done solar cell experiments before? No? Have you heard of solar cell? Yes. Have you seen one on top of roof? Yes. So today we're doing solar cell, but a little bit different because we're focusing on dye-sensitized solar cells. Okay, so I hope that you would get into the physics lab and go into this goal number 7. Please don't get me wrong, we're using different laboratories that are not chemistry laboratories, but we're doing chemistry experiments. So when I say physics lab, it's literally the lab is called physics lab. Okay, so when you enter that lab, you will learn about DSSC, right? The types of dyes that they use to kind of coat the titanium layer, and then you would fabricate your own DSSC and hope to light up a tiny little bulb that you see later on that way. So I hope that you would kind of participate in the experiment and try your best to fabricate one and see if your efficiency is higher on the leaderboard. Now the next thing that you would be doing is the water electrolysis experiment. Can you just continue to flip these? So water electrolysis experiment, anybody done it in school already? Yes. Electrolysis. Is that in chapter, form 5? Yeah, nice. So today, I think you'll be experts in this experiment. Basically, we're trying to utilize this as a concept for you to learn that water can be split, obviously, and the hydrogen gas that's produced from these processes, of course, could be then utilized to power fuel cells. The one that we're doing is just a tiny version to showcase that water can be split, and yeah, to give you some ideas that there are something like water splitting, something called artificial photosynthesis that will be introduced in our day-to-day, that is progressing in terms of research right now. Okay, can you guide me through what's the next goal again? What's the next goal? Yes, industry, innovation, and infrastructure. Right, a lot of you might think, what is chemistry's relevance in these kind of industrial and infrastructure-related area? Like, it's totally different field. You think of chemistry as just going into the lab, mixing things, seeing, observing change, and it has nothing to do with industry or infrastructure. But that's wrong. Chemistry, like I mentioned before, is the central science. It has the ability to go to various places, including material development, that will then be used in these areas. So what you can see is booth number 3, it's also in the physics lab. It says testing the strength of materials and corrosion protection. So what these 2 experiments are doing is to showcase that as chemists, you can study material properties. You can be making polymers that exhibit certain properties to then be utilized in areas like infrastructure, industry, and innovations. Okay? So in addition to that, corrosion protection is also another area that we should focus on. You know that how if you leave something outside, like a metal nail, for example, over time exposed to the environment, what does it do? Rusting, yes. So that is a very bad thing because when rusting happens, it will deteriorate the material and it will lead it to have no strength as much as it starts with. So with that said, chemistry can actually be employed in areas of corrosion protection so that you can then extend the lifetime of these materials in the industrial context. So do know that all of the experiments are carefully planned for you to understand that chemists play an important role in all of these areas. Okay? Responsible consumption and production. So in responsible consumption and production, how many of you used a box that is biodegradable for your food? How many of you? Do you still use polystyrene for your box, your takeaway boxes? No. We have progressed, right? So that means that there should be some research done in this area to actually give us that ability to change the existing materials that we have into better materials. So one of the experiments that will be showcased today is called the making of bioplastic. I hope that you'll stay tuned to this experiment in the chemistry lab. And you'll have this in the chemistry lab. And hopefully you get to make your own bioplastic to take home. Okay. Lastly, guys, what's our last goal? Okay, so you don't even need to check because you know the importance of it. So the last goal is called climate action, and the experiment that we'll be covering in today's YAC program is called waste to wealth. Have you heard of biodiesel? Yes. So bio in that context refers to biomass. Yes, biomass. Right. So you are going to do an experiment where you'll be synthesizing biodiesel using used cooking oil. So we'll have a series of experiments where you're doing the tiny vial. Of course, there will also be demonstrations at the beginning to show you how it works. Okay? Anybody make biodiesel before? Right, so that's a very brief coverage of what we'll be having today as part of the YAC program. And I will leave it to the good hands of our demonstrators in the respective labs to help you with those experiments. Okay? Now, just to kind of give you a little closure before I end this, is how chemistry could actually make an impact on climate change, right? By lowering down greenhouse gas emissions through various research that are done or initiatives that are made at the moment, we can actually reach towards net zero in terms of carbon emissions by 2050. The reason for that, for us doing so many things, is because we hope to see Mother Earth, a happier Mother Earth. And when Mother Earth is happy, we'll be happy too. So that's the general context that I would like to bring through today. So in conclusion, through chemistry, we can promote sustainable development goals towards achieving sustainable development, and contribute towards achieving, what are the 5 goals again, please? SDG 6, 7, 9, 12, and 13. Right, thank you. So by incorporating these experiments and the activities done in today's session, we hope that you will be able to bring forth educating more people about it and be involved in sustainable development research when you get the chance to. Okay, that's it. Thank you very much for your time, and this is my project.
Thank you, Dr. Yvonne. Okay, so we are near the end. So before that, let me thank once again yang berbahagia dating Dr. Zuriati, yang berusaha Mr. Yaya, yang berusaha Dr. Sim Siong Fong, and also yang berusaha Dr. Yvonne. Please give a round of applause for them.
Have it earlier so that it will be easier for you just to pour it. Don't start water, vinegar, and glycerin. So the first thing you measure 4 tablespoons of water. This 60 ml. This one what? This measure. That's teaspoon. In 16
So this is deionized water. What is deionized water? Okay. You know?
About 10 of the yeah, it will be spread over the years. Then look at the two things. The first, the top part is fatty acid. Top is what biosystem. And the bottom part will be the glycerol. Kita jadi international lah.
Yeah.
Got one more. Come on, Raymond. Don't you kill Raymond.
Okay, now you heat it on the heat platter. The glycerin to break down the vinegar. The vinegar is the heating. The heating is this to support and to make it easier to stir. Right, miss?
Well, when you heat it up is when you want to have it to dissolve. Yeah, then only you can turn it into paste. Yeah, this starch is I forgot to record. This starch is it's thermo responsive. Yeah, you will need to heat it so that it can reach gelation temperature.
So basically when you observe, you can only observe color and how to be this sun. Okay, from smell. But smell, how do you smell certain cells? Like, do you straight away do like so you have to, you do not directly smell anything at all. Even your perfumes, I don't see people going like they always more on paper. I told you. Because we want to make the pH, but the color is like different. And then 5 types of sauce here. So you can see we do have this machine. Later you will drop the sample every circle, 4 to 5 drops, 3 to 5 drops here.
If we add acid sodium hydroxide, that will form colorless solution. Okay. How about manganese? If we add acid sodium hydroxide, it will change to brown precipitate. Okay. Same goes to this blue for copper, green for iron 2, and brown silver and iron. These are the cation. Okay. However, this one is for anion. Okay. Then, firstly, take this 16 tube and arrange it in a proper order. After that, label the test tube number 1 until number 16. Okay. The reagent or the chemical is already arranged. Number 1 up.
Okay, so we're going to proceed to do the experiment. Okay. So with the sample cell, so what's the sample cell? It's on you. If you can't see, hold it by the neck, and pour the sample up to the filling line. You can see there's a line on the bottom. Catch it.
add 3 drops of silver nitrate. Do you have, can I have your worksheet please? No, that one.
Sorry,
Yeah. These are the real samples. Water source A, B, C, D, E. So you have to write what is the finding here, the observation. So the cation test and the anion test. Okay? This one.
very good.
Check again. Put 老很长的，比我们还要老。我还以为你学校比较好，没有了，那几个大个的学生。
Can see your a bit. All good here? Yes. Oh, blue color? Oh, ya ke?
So I have 3 more, right?
This is from which school?
Hitung kuat-kuat.
I need to send the sample to the Jabatan KIMIA. That's right. So Jabatan KIMIA do the give the result. I can have the tangan.
Zero. Okay, so the one with the reading will be considered to identify. So you need to correct this is then you can see how to do experiment. We are going to see in what condition the meal, that means the steel will work, in what condition the steel has protection. So this one is the thumb pin. Okay, so you can see here. But today our plastic is like quite rigid, cannot stress. Okay? So, and then rubber. Rubber you can easily observe when you apply a bit force, it comes out. This one is what we call, this one elongation is happen. And then this one we call what? Stretchable. Elastic property. Elastic property. Okay? So, and then we go to this one.
So, second, carbon dioxide is produced, but we don't know which one lah. We can't tell whether it's carbon dioxide or oxygen gas. The only way we can tell is maybe we can use a wooden splinter and see whether it pops or whether it ignites. Okay, but for the other side, for the cathode side, they produce hydrogen gas. Okay, so when sodium bicarbonate reacts with water, hydrogen gas will be produced. Okay, it's not the sodium metal. Okay, it's the hydrogen gas because hydrogen is less reactive. Hydrogen is reductive
without leaving any space on top of this chip. Which I think you have to make sure your hand only release when the chip is inside the water.
My hands are very
like you to be a little patient, but you will see something that you have not seen before. Can you add approximately? I think some of you can also come and put this together. About 25 minutes, roughly. 25 minutes. Yeah, each and every one. And I'm going to add these 4 sensitizers. From your left, diphenyl anthracene. Okay. The next one will be rubrene. Just give us a little time to organize things. Yeah, that's good enough. Rubrene, the same things that you see from there. Then the third one, don't change the order of them. Third one is this one. I'm going to put pedaline. No, third one. Ooh, I messed it up. Yeah, give another one.
There's another conical glass right here.
Okay, so that will be the second one. Oh, I will need a 4th one. Okay. All right. Sorry, because I'm a little mixed up here. Rubrene. Okay. Okay. So no problem. Thank you. I will put rubrene here. No, don't move. Don't move anything. Don't move the order. Okay. I'm going to put green there. And yeah, now you put ethyl in both of them. Yeah, so don't change the order. Just pour it. Yeah. No, I am just going to pour it like this. Okay? Yeah. 1, 2. Then this is for the mixture, right? Mixture you have removed. Okay. So now I'm going to do the only last two. No. We will try perhaps at the end. Sorry about the little delay, but you will be rewarded. That is done. And finally, the tetracene. Yeah, a little bit of stirring. Yeah, this tetracene that I am going to use that looks like 2 naphthalene, that is tetracene, right? Last one. Okay. This is pretty expensive. About 100 milligrams cost about 500 ringgit. And that's where my contact with Mud Sigma Aldrich helps. Okay, and then to get this diphenyl ester of oxalic acid, I think that's good enough. I'm going to put a generous amount of these into each. This is actually safer to use than oxalic chloride. Oxalic chloride gives a very bad acid fume, so in a small room like this, you can close it. Yeah. Okay. Thank you for your patience. And hydrogen peroxide is here. Okay, the last two I will do it later. Okay. So, boys and girls, are you ready? For 3 minutes, but then I may take another 5 minutes or so if you don't mind. Blue, violet, and orange. Okay. In completely dark room or at night, it looks fabulous. But then this is the best we can do. And then you also remember blue and orange are complementary colors. So what we are going to do is to first show you blue, violet, and orange, and then I'm going to mix them. It will show. If all goes well, it will show orange, then white for a few seconds, and then blue again. Alright, let's get going. I hope it works. Blue, violet, and orange. Blue, violet came for a short time. Why? I think I just need a little more study. Do you see the blue violet?
Yes.
And it's cold light. There's no heat here. I must say that with oxalic chloride it works much better because I did have to keep stirring it because of the sodium bicarbonate is insoluble. And now you see the beautiful color. And I'm now going to do a titration. Okay, in the sense I'm going to add orange to blue. Now you see it is orange. Okay, it will become white for a short time and then blue again. Still orange or yellow. Just be patient, even though my clock is ticking. I have 1.5 minutes. Alright. It will become white for a very short time. It still has a small hue of orange. I think it's working, but I have to keep stirring it. That's the problem. That's why you are making the stirrer. But you have not made the stirrer yet. So, the next workshop is going to be stirrers. Okay, maybe I will ask one of you to keep swirling it when I show the other experiment. So this will become sky blue and this is going to be green. That is becoming white and then it will go blue again. White will stay for a very short time. Yeah, I think that is nearly white now. And now I have sky blue and green on your right. Do you see sky blue appearing here?
A little bit.
This is sky blue?
Yes.
You know, with this one, with this particular oxalate derivative, it's a little tricky. And here also you can see a bit of green color. It's coming out.
Yeah.
Ah, this is white. Now you see it's white, you keep swiping. Okay, one of you can take turns. So as promised, we got orange, we got sky blue, and we got green from tetracene. Okay? So this is a way to, you know, generate cold light or light from chemiluminescence. And I'm so happy. Yeah, this is white now. Okay. So this became odd, but I think I added a little too much orange. Usually the orange light does not stay for too long, even it's done with oxalate chloride. But in order to understand what's going on, why some of them are appearing at different colors, you need to understand a lot of photophysics and photochemistry, because some of them undergo chemical reaction and they decompose faster. Okay, but I want to make sure that you don't get it. Alright, are we ready? Okay, let's see what comes up. Alright, one liquid color. Initially it was completely unbelievable. So it looks like magic, right? Okay, so thank you very much. You can remove your glove, remove the safety goggles. So this is a way to highlight the importance. Now I'm going to add sodium iodide to this, okay? But then if I add sodium iodide, it does not prove that iodide is the catalyst. It can be that sodium is also the catalyst. What experiment should I do to prove that it is sodium that is not a catalyst, but iodide is the catalyst? I will use some other sodium salt. Okay? So that's what I'm going to do now. So this is sodium iodide, 1 ml of water in this. But before that, I will add some sodium bicarbonate, right? Baking soda. I'm using most chemicals which are household chemicals. In fact, baking soda has saved my life. I will tell you why. For the last experiment. Now I added baking soda, nothing happens. No oxygen, right? So sodium is not a catalyst. Bicarbonate is not the catalyst. Yeah, that's the question now. Just yeah. Okay. Just so that another element. So just to make sure that they interact, they mix properly, I have added some water to the sodium iodide, and I need to be careful because there will be a big mess here, and my presenter should not. And here comes the toothpaste. Okay. So thank you. The hydrogen peroxide was good. Ooh. I hope we can contain the foam. No? Alright. You know, there are so many of us, we are all taking oxygen and liberating CO2. So it's good to make some oxygen. And it's a safe experiment because you see some fumes coming out, but that's nothing but steam. And I get a nice smell from the soap. Okay, nice smell. So this is a fun experiment, but whoever cleans it up, make sure that you wear gloves. Right? Okay, and this goes with it. Okay, because both are contaminated. Yeah, I want it here. I'll put on the lower side, so you can see partly it is yellow on the top and it is orange at the bottom. Okay? Done? Okay. I'm going to put a little bit of that here in the measuring cylinder. Okay, you can see what's happening. You see the pink color?
Yes.
Okay, that's all that I need. So the first one, I'll tell you in a minute what's going on here. You might wonder, why am I doing this? So I've got, shall I blank it? Yes, this is going to be an experiment with light. This is last but one experiment, I believe. So I have a red laser, I have a green laser. 532 nanometers, 617 nanometers. Which one has higher energy? Green one. Alright. First example is transmission. If there is no dust, you will not see the light beam. Right? You don't see the light beam. Green or with red. Okay, now the middle one, milk. What is the difference when I have milk? It will scatter. Okay? Green, you see the light beam?
Yes.
See that? With red, you see the light beam. Alright. Now I probably put too much milk. If I dilute it, you will see the beam all the way going and hitting the floor. I think it's hitting the floor. Okay, it is hitting the floor. But the transmitted light is green, transmitted light is red. Last one. Why pink highlighter? Because you will see a magic. Now, in addition to the dye, there are also things like silica gel so that the dye spreads on the paper. So you will see scattering. With red light, you see a beautiful scattering light, and the transmitted light is red. Transmitted light is red. Okay, let me hold it like this. Alright. Now if it were like this, I will not show the experiment. But something magical happens with the green laser and the pink highlighter. So what was the color? Bring the milk. This is scattering. Magic is fluorescence. Okay? So this 532 nanometer light, one second, escape. 532 nanometer light is absorbed by the dye and it goes all the way down, and then now it is absorbed, it has absorbed almost all the light and there is no transmission. Okay? But I can demonstrate Beer's law by reducing the concentration. Some more water. Because the lesser quantity will allow less absorption of the green light, and now it will go and hit the bottom. B. Now you see the transmitted light is green. It is only because of the dye. I will hold it here. Transmitted light is green. Okay? And what you see is a beautiful yellow-orange fluorescence. It is conversion of shorter wavelength into longer wavelength. That's why I said it's very important to describe this as a pink highlighter. If you simply say highlighter, your experiments will not work. Thanks to Imperial Hotel, you put the same volume. Okay, this does not have quinine. And I brought the Indian tonic water about the same volume. Okay, now we would like to know which one is which. Can I have the lights off, please? Lights off, please. Okay, that's okay. And then you move things around. This light is also off. All lights off. No, you keep it here so that I don't know which one is which. Okay, I close my eyes. Okay, one of them is quinine, has quinine, the other one does not. Alright, but the one which has quinine will show fluorescence. Do you see any fluorescence? No. Do you see any fluorescence? Yes. Yes. Right? Yes. And you can see this nice blue fluorescence of quinine. I think the room could be a little darker. In a completely dark room, it will look much nicer. But I think you get the picture, right?
Yeah.
Yeah, you can put it in the background. The other way. Yeah. White. White. Okay, now you can see this. Okay, and side by side I will use Sprite. 1 second. You want Sprite? You see nothing. Right? You see only transmission. So, if you have a small UV torch, UV flashlight, you can do this experiment rather easily.